The volume of a cylinder is given by pi r squared h. Given r is equal to 5 cm and h is equal to 10 cm, find the approximate increase in volume if r increases by 0.2 of a centimetre and h decreases by 0.1 of a centimetre. We know that v is a function of radius and height, and we also know delta z is equal to dz dx times delta x plus dz dy times delta y. So changing z for v, x for r and y for h, we can write delta v is equal to dv dr times delta r plus dv dh times delta h. So now we need to find dv dr and dv dh. So we're going to differentiate this expression with respect to r and then differentiate it with respect to h. So differentiating with respect to r, we've got r squared, so we're going to get 2 pi r h. Differentiating with respect to h, we're going to get pi r squared. Substituting those values into this equation here, we're going to get delta v is equal to 2 pi r h dr plus pi r squared dh. Now, what we actually want is not delta v, but delta v over v. So I'm going to divide the left-hand side of this equation by v, and I'm going to divide the right-hand side of this equation by pi r squared h. That gives me delta v over v is equal to, for the first term I can cancel pi r and h, pi one of the r's and h, and that's going to give me delta r over r. And for the second term I can cancel pi r squared, and that will leave me with delta h over h. So that gives me delta r over r is the percentage change in radius. Now radius is 5 centimeters and it increases by 0.2. So 20 times 5 would give us 100, so 20 times 0.2 would give us 4%. H is 10 centimeters and it decreases by 0.1, so 10 times 10 would give us 100, so 10 times 0.1 would give us 1%. We've increased 4% on the radius and decreased 1% on the height. So 2 times 4 is 8, 8 minus 1 will give us a net change of 7%.